Assalamualaikum and salam sejahtera. For question 1, we have function x minus 1 power of 1 over 3 and x plus 2 power of 2 over 3. So the question 1, we need to find the critical number of fx, the point of which fx has relative extremum, interval on which fx is increasing or decreasing, the concavity, and plot the graph using GeoGebra. So first, we need to find the domain. So we look at the exponent at the function. So since the denominator of the exponent as in 1 over 3 and 2 over 3, so this is a cube roots. So the cube roots, we know that can accept any number, positive, negative, or 0. So since the odd number doesn't have a restriction, so the domain is a all real number. So the domain is negative infinity to infinity. So second, we need to find the critical number. First, we need to find the first derivative. So first derivative, how we can use product rule and chain rule. So like product rule and chain rule. From that we can simplify until we get of the answer is this, and then we do the first derivative equal to 0. So look at the numerator, we get x equal to 0. So we can say first derivative is fx is undefined at x equal to 1 and x equal to minus 2. So the critical point that we get is minus 2, 0, and 1. So to find the increase and decrease and extremum, we use test number like integers, and we took the number between the integer. So if this, we choose minus 3 and we put minus 3 into the first derivative, and from that we get the first derivative is positive or negative. So if that positive, that means fx is increasing. So we go with all and we get increasing, decreasing, increasing, and increasing. So from this test, we know and we get the relative minimum numbers at x minus 2 and relative maximum at x minus 2 and relative minimum at x equal to 0. Because since the graph goes increasing to decreasing at s equal to 2, so that means at x equal to 2 equal to negative 2, we get relative maximum. And since goes decreasing to increasing at x equal to 0, so we get relative minimum at x equal to 0. Then if we put the negative 2 and 0 at the function, we can get the point. So and then to find the concavity, we need to find the second derivative. So to find the second derivative, we use quotient rule. That if you think that difficult to use quotient rule directly, I think you can use this, like you search what all this first, and then after that you simplify until you get this second derivative. and then the second derivative we need to equal to 0. So from that we didn't get the, so the second derivative is undefined, but we have the nominator that x equal to 1 and x equal to -2. So from that we can use the test for second derivative. So we all same, we take the number between the integer and put the numbers into the second derivative function. So from that we can know the concave is upward or the concave is downward. So from this test we can know the x equal to 1 is the inflection point. So to sketch the graph, we put all the point we get before, like if at x equal to 2, this point, this point, we and this point we put together and we can make the graph. That's all. Thank you.
Question 2. So for A, they were asking what is the rate of change of the perimeter when the length of an increasing side is 5. So first of all, we need to write down all the information given and what we need to find. So here, the LDT rate change of the length is 2 and the area given is 50. So what we want to find is dp per dt when L is equal to 5. So the first step is we need to express W in term of L using the area equations. So here, width equal to area over length, so 50 over L. So next, we need to write the perimeter equation in term of L. So here I write P equals to 2L plus 2W. So we will solve it and we got P equals to 2L plus 100 over L. Next, after we got the perimeter equations, we need to differentiate respect to time. So dp over dt equals to 2 dl over dt minus 100 over L square dl over dt. So right now, we already get the differentiable equations. So next, we need to substitute the information given, which is L equal to 5 and dl over dt equals to 2 into the equations. So substitute and then we will get the answer dp over dt equals to -4. So that's all for question A. Next, we will proceed to the question B. They were asking what is the rate of change of the perimeter when the length of an increasing side is 10. So basically we use the same equation from part A, which is dp over dt equals to 2 dl over dt minus 100 L square dl over dt. So we just substitute L equals to 10 and dl dt equals to 2, which is given, into the equations, and then we get the answer equals to 2. So for question C, they were asking what are the dimensions when the perimeter ceases to decrease. So basically, the perimeter ceases to decrease when dp over dt equals to 0. So information given from the equations above is dl over dt equals to 2. So we can substitute and solve for L. So substitute 0 and 2 into the equations. 0 equals to 2 dl over dt minus 100 over s squared dl over dt. Solve the equation that we already substituted just now. And then we will get the length equals to 5 square root 2. Next, we can find the width when L equals to 5 square root 2. So we find the width and proceed with the works, and we get width equals to 5 square root 2 or 0.07.
Question 3. The total cost of producing X radio set per day is Rm104x squared plus 35x plus 25, and the price per set at which they may be sold is Rm50 minus 102x. A. What should be the daily output to obtain a maximum total profit? So it's an optimization question. We need to follow 5 steps in order to find out. So the first, we need to identify what variable need to be optimized. Since they're asking maximum total profit, the total profit will be the total price minus total cost. Since here they're given us only for one set for the price, so we need to times with x and minus the total cost here. Then will be Rm negative 304x squared plus 15x minus 25 for the profit. Second step, we need to express this as a function in one variable so that we let fx equals to the profit and get negative 3 over 4x squared plus 15x minus 25. Since it's already in one variable, so it's done for the function. Then we need to find out the domain of fx. Is there any endpoint there? So since it's a quadratic function, so that the function will be continuous at all points from negative infinity to positive infinity. Then the fourth step, we need to find out the critical point. Critical point is let f prime x equals to 0, which is dy dx equals to 0. And then we find the dy dx for this function fx is using the power rule, which is the 2 we add here, we times with in front and minus 1 here. So we get negative 3 over 2x plus 15. Then we do calculation, x equals to 10. So that last step, we need to find out the x equals to 10 here is either maximum or minimum by doing f prime prime x. So f prime prime x equals to, also using the power rule, which is the power here 1 times with the in front and minus the power 1. So that we get negative 3 over 2. Since there's no any variable here, then we just get f prime prime x equals to this value, which is smaller than 0. So smaller than 0 will be maximum. If f prime prime x is bigger than 0, then will be minimum. So that we can know that the daily output should obtain in order to get maximum total profit is 10 set of radio. Come to the question B. They need to show the cost of producing a set is relative minimum at that output. So same as just now we done. The first step will be find out the variable that need to be optimized. So need to be minimum is the cost of a set. Find out the cost of a set is by using the cost, the total cost that they given on top, divide by the total set. Then we obtain 1 over x plus 35 plus 25 over x. Second step is let gx equals to cost of a set. So that since it's also one variable, so that gx will equals to 1 over x plus 35 plus 25 over x. The third step will be domain of gx. Since the function here, we have 25 over x, so that the x can be any value except of the 0. Hence, the domain for gx will be negative infinity to 0 and union with 0 to infinity. So they're continuous at all points except for the 0. Then the fourth step will be find the critical point. So that for the critical point here, we need to use the f prime x, also we call g prime x for here, will be 1 over 4 minus 25 over x squared equals to 0, and find out the calculation x equals to plus minus 10. So x is an output, they cannot be negative, so that x is positive 10. Then we have to check out this output is whether they're maximum or minimum for the cost by doing the g prime prime x. So we equals to 25 over x cubed. So that we substitute 10 here into the x, then we get 0.025, which is bigger than 0. Since f prime is bigger than 0, so means they are minimum. So that we can do conclusion that the f prime x equals to 0.025 is greater than 0, so cost of producing a set is relative minimum at that output of 10. So that we have shown that the x equals to 10 we produce here is minimum for the cost of producing.
Okay, Assalamualaikum. Today we're going to discuss the SL question, which is question number 4. I'm going to discuss the one Roman and second Roman. Today we can saw here the equation. Okay, we got the 0 over 0. So we use the formula if the lim x limit approach to C plus of x fx equal to lim x approach to C plus gx equal to 0, we can assume that lim x limit approach to C plus fx over gx equal to limit x approach to C plus fx prime over gx prime. So we can use this formula, and the limit x approach to 0 sine 3x over 4x, we just differentiate and we got the limit x approach to 0 cos 3x times 3 over 4. Therefore x we differentiate, we got 4. The sin 3x we got cos 3x times 3. So we just substitute the limit x approach to 0. As we can saw here, that cos 3x, we got cos 3 times 0, we got a cos 0, we got 1. So when cos 0 we got 1, we can get 3 over 4. That's a final answer for the one Roman. And the second Roman, we just use the usual term, same term, which is we can saw here that when we substitute the infinity, we got a 0 over 0. So we just differentiate three e power of 2n and the denominator 4n power of 2. So we just differentiate as usual. We got a c e power of 2n and the denominator we got a 8n. So we just substitute the infinity into the equation, we got a infinity. That's a final answer. Thank you. That's all.
Okay, let's look at question 3 Roman. The limit as x approaches 0 from the right of x squared ln x. So from what we can see here, this limit gives 0 times negative infinity. So I rewrite it as a fraction. Then I apply L'Hopital's rule by differentiating the numerator and denominator. After simplifying, I substitute x approaches 0 and obtain the final answer, which is 0. Next, for the question 4 Roman, the question states the limit as n approaches infinity of n times e to the power of 2n. So, from what we observe here, as n approaches infinity, both n and e power 2n increase without bound. So, since exponential functions grow faster than polynomial functions, the product also approaches infinity.